Alright, looking at patterns and sequences. When we look at these, the easiest way to start is to always start with n. So you're going to make this little chart, right? I'm going to start with n, and then f of n is a function of n. Okay, so n is always going to be the number of terms you have. So there's 1, 2, 3, 4 numbers. And f of n is going to be what these numbers are. So 1, 4, 9, 16. Now just by doing that, I've simplified this style of question. What do I need to do to 1 to get 1? Well, I could leave an 11. But if I do 2, and I just leave an 11, this should be a 2. So that doesn't work. But 2 times 2 is 4. Now let's check. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. So your function is n squared. Because 2 squared gives you 4. 3 squared gives you 9. And 4 squared gives you 16. Alright? Let's try the next one. 54, 52, 48, and 40. So let's see if this same principle applies. Well, 1 times 54 gives you 54, right? So if I was just going off of that, I would say it's 54 times n. But if I do that here, 54 times n, it's not going to work out so well. Because that will give us 108, right? So this method is not going to work for that. But we could start with a random point and check and see how these numbers change. So it goes down 2, down 4, down 8. Okay, now if it asks us to name like the next 3 numbers in the sequence, we could say, well, went down 2, 4, 8. Now it's going to go down 16. Then it's going to go down 32. And it's going to go down 64. That's not really going to help us with getting a function. Okay, so I've been thinking about this one, and if we look at this pattern, it does go down over and over again, but there is no official sequence that we can write to come up with the way to like process how it's going down. You know what I'm saying? So really, the only way this one would ask us something is it would ask us to write the next 3 terms or something like that. Kind of the same thing here. Goes up by 8, 16, then 24. So we could do the next 3 terms. The other thing we could do for this one is we could start with the fact that we know it starts at 2. And then we could do 8 times. Then the difference from here to here is 2, 10, 16, and 24. So the difference from here to here is 8, which would be n minus 1. So if you're finding the second term, you would do 2 plus 8 times 2 minus 1, which would be 1. So 2 plus 8 gives you 10. And for this one, you will plug the 3 in here. And you would do 2 plus, and then it would just be 8 times, sorry, I screwed that up. It should be 26 and 50. Sorry. If the difference here is 8, then it would be 3 minus 1, which would be 2. 8 times 2 is 16. So that's how you come up with your difference in here. It's not perfect, not a perfect system, because we're still adding that to the previous term. So like it worked for 2 in the beginning, but it's really just going to be n minus 1 plus 8 times n minus 1. All right. On to the next one. Here we have 41 going down to 37, 33, 29. So we're subtracting the same thing each time. And so it is just 41 minus 4 times n. That's when it's an easy one, when you subtract the same thing each time. Now these are the ones that you're generally going to see. You might see one like this, but it's going to be more the ones like this. So then all you would have to do is plug that in. Now to ask you like find the 41st term or the 40th term or something, so you would just plug that number in for n. So you would do 41 times n, or 41 is n, so you would do 4 times 41, be negative 164. 41 minus 164 will give you your answer. And you'll see on your worksheet, the answers are much easier than these questions. Okay, so that's really it for patterns and sequences. You're just going to look for what the pattern is, try to establish that, and then go from there. The other option is going to be to plug your answer sources in. Whenever we go over this homework on, or this packet on Friday, we'll look at some of those options as well.